Okay, so we're going to be talking about matter, and chemistry is basically taking a look at the properties of matter. What is matter made of? So that means its composition, and then how does matter behave? Okay, so matter is anything that has mass and occupies space. So I would make a note of things that's not thick enough. That's better. I would make note of things that are not matter. Okay, so for example, heat and things that aren't matter would be like light and sound. Okay, because these things don't have mass. Okay, because they have to have both mass and occupied space to be matter. Okay, and mass is the amount of matter that's in something. We typically measure mass in grams, and then there are a ton of different properties that we use to describe matter. And properties are qualities of something. They allow us to group things together. The first types of properties that we're going to talk about are extensive and intensive properties, and there are a number of different examples that they give you. So for extensive properties, these depend on the amount that you have. For example, mass and volume, extensive properties. Also, if I'm looking at a metal wire, like copper wire, how thick it is and its length influence its electrical resistance. So electrical resistance of a copper wire would be extensive because it depends upon how much I have. The flexibility of a metal sheet. Okay, so that's going to depend upon how thick the metal sheet is, because if I have aluminum foil, which is not very thick, that's super flexible. But if the aluminum is really thick, I'm going to have a hard time bending it. Okay, intensive properties do not depend on the amount that I have. Okay, so these would be things that are like constant for something that's pure. For instance, the melting point of a pure substance would be an intensive property. It doesn't matter how much ice I have, it's always going to melt at the same temperature. Density of a pure substance as well would be an intensive property. Like gold, pure gold would always have the same density. Okay. Other things that can be used as intensive properties would be things like temperature, concentration, and tension. Now, there's a few that are not listed here that I'm going to add just in case. So let me do this in a different color. So some other extensive properties would be the heat capacity, which I'll talk about later, of a substance, thermal energy, which we probably won't discuss in too much detail. Thermal expansion we'll never discuss, but I'm just giving you these things because I often have students use these books as references when they go to college, okay? Intensive property examples, I'm going to put some others over here. Specific heat capacity would be one. And then boiling point would be another. Okay? So every substance has extensive and intensive properties, and we could use the intensive properties to identify what we have. Let's turn to the next page. On the next page, they talk about physical properties, chemical properties, and physical changes and chemical changes, okay? So let me move this, and let's start with physical changes. So physical changes are changes of state. Let me give you an example. If you convert a solid into a liquid, and maybe a liquid into a gas, and vice versa, those would be physical changes. Physical changes tend to be reversible. Okay. Examples of physical properties which can be used to identify something would be the melting point, boiling point, color, hardness of something. Okay. Let's talk about chemical changes for a second. Chemical changes are when a new substance is made. Chemical changes are typically not reversible. So if I burn a piece of paper, I can't make that burnt paper go back into what it was before. So that's a chemical change. That's not reversible. Okay? Chemical properties tend to describe the tendency of things to undergo chemical changes or react. So chemical properties would be things like, is something flammable? Is something reactive with other chemicals? Is that substance going to rust? Is it going to ignite? Etc. Okay? There are a lot of other physical properties listed within this next paragraph, and I'm going to highlight them in the same color as what I highlighted physical properties up here, just so you have them. So if I'm looking at some electrical or magnetic or optical or acoustical properties, or maybe something is radioactive, those would be examples of physical properties as well. If something is transparent or it's opaque, that would also be a physical property. Okay, things that you might have learned in the past that are physical properties would be density, viscosity, and surface tension. Density we've done a lab on, we've done math problems related to it. Viscosity has to do with how thick a liquid is and how readily it flows. So viscous substances, it would only be appropriate to use that term if you were describing a liquid. Okay, so to give you some examples of viscous substances that you guys are familiar with, I would put motor oil here, or honey, or maybe molasses. And those are all thick liquids. They flow really, really slowly. Okay, and you can actually heat up liquids, like you guys have probably heated up honey before, and it makes it runnier, and that's because you break the intermolecular forces between them and you make it less viscous. Okay, surface tension you guys probably talked about in biology. Surface tension has to do with that sort of skin that forms on the top of liquids, usually liquids that hydrogen bond. So water has great surface tension in it because you can pour it to the top of a glass and it forms that brim on the top. Okay? Okay, can I move this down? Okay, so let's take a look down here at how the particles are related to each other. So when we undergo physical changes, we're going to move the particles around. We're not going to break any bonds. So let me give you an example. For physical changes, if I have a solid and I'm converting that solid into a liquid, solid particles like in ice, those particles will be packed as close as they possibly can to each other, and it will look something like this. Okay, I can't compress it any more than it already is, and there's minimal space in between the particles. If I heat up a solid like ice, then I will form a liquid eventually, and the particles will actually spread out. So you'll see these particles with a little bit more space in between them. So they would look something like this, and they can slide over each other. They may touch, but they have the ability to move about each other with a little bit more freedom, okay? Okay, now, if we're talking about chemical changes are where you have to regroup the atoms themselves. So let's do an example of a chemical change. Let's do that down here. So if I have a water molecule and I'm going to break that water molecule apart into hydrogen and oxygen, okay? my water molecule may look like this, right? Because I'm going to have 1 oxygen and 2 hydrogens attached to it, okay? When we undergo a chemical change, these atoms all break apart from each other. So what will happen is the hydrogens will now attach to each other rather than to the oxygen, and then the 2 oxygens will attach to each other like that. Do you guys see the difference? Okay. It usually takes a lot more energy to make a chemical change occur, and they discuss that here. It says physical changes generally involve less energy than chemical changes. And that makes sense because, like, I could make a piece of ice melt by simply holding it in my hand, but there is no way I can make water molecules break apart by just holding water in my hand. This would take a lot more energy, okay? Okay, any questions for me? So what I just drew you, these are particle diagrams, okay? So if you're ever doing a lab or a worksheet and I ask you to give me a particle diagram of something, I'm asking you to draw it like on the atomic scale, which this is, okay? All right, let's take a look at the next page. Okay, kinetic energy, which is usually abbreviated as KE, is energy that isn't stored. This has to do with energy of motion. So if you're running down the street, or we've got molecules moving all over the place, or gas particles colliding with the surface of their container, that's kinetic energy. And the greater the speed, so the faster you're running or the faster the molecules are moving, the greater their kinetic energy, okay? And kinetic energy that the particles have is usually called mechanical energy because they're constantly moving. There are 3 forms of motion or mechanical energy that particles have. Number 1, they can move from place to place, which is translational. Number 2, they can rotate. And number 3, they vibrate in place. So they just move back and forth, okay? If I add up all of the different motion that particles have in a sample, that would be called the thermal energy. Thermal energy is an extensive property because it depends on how many particles I have in that sample. Temperature is actually the average motion that you have of all the particles in a sample of matter. It doesn't depend upon how many particles I have. So therefore, it is an intensive property. Okay? So if the average speed of particles increases, the temperature increases. If I have a bathtub full of cold water, or I have a cup of boiling water, wouldn't there be more particles in a bathtub full of water? Okay? So if I add up all the motion that the particles in the bathtub full of cold water have versus I look at the motion that the water in a boiling cup has, then I would have more thermal energy in the bathtub because of all the particles than I would in the cup of boiling water, okay? Okay, let's come down here and let's talk about how we actually take the temperature of things. We don't use the old school thermometers. We use the digital thermometers in here, and they're typically wireless, but let me explain to you how you get this liquid alcohol to rise in a thermometer. So in these thermometers, let me stop this first.